day one homework prep. First side is classify polynomials. Go ahead and copy down your learning objectives. We're going to classify polynomials according to the number of terms and their degree. So let's talk about the number of terms first. Okay? So Roman numeral 1, number of terms. Copy down these 4 terms here. Monomial, binomial, trinomial, and polynomial. Okay? With the number of terms, each term is separated by either a plus or a minus, or an addition or a subtraction. So if you're talking about a monomial is just one term. If you have just one term, that means you will have no pluses or minuses. Please copy that down. If you have a binomial, well, you guys know the prefix bi, like bicycle, it means you're going to have 2 terms. In order to have 2 terms, you're going to have 1 plus or minus. Okay? For a trinomial, like tricycle, that means you're going to have 3 terms. Well, if you're going to have 3 terms, that means you're going to have 2 pluses or minuses. And lastly, for polynomial, poly is a prefix that means many. It means you're going to have more than 3 terms. So I'm going to say greater than 3 terms. And what we'll say here is we'll just have many pluses. I'll put and minuses. Okay. Let's take an example. Let's look at a few examples here. Copy down these 3. And let's talk about these so we're comfortable with them. And number 1, you can see here that there is 1 plus. That plus separates those 2 terms. Separates the 2x squared and the 3x. Since it's separating those 2 terms, that means we got to have a binomial here. Write that down. Okay. Take a look at number 2. Number 2, you'll notice we'll have no pluses or minuses. There's just 1 term there, 1 multiplication clump, 5 times x to the 3rd. With no pluses or minuses, this is just 1 term. We call this a monomial. And for the last one, here you can see we have many pluses and minuses. Here we actually have 1, 2, 3. Well, it's going to separate those 4 terms. So anything greater than 3, we just say this is going to be a polynomial. Okay? All right, let's talk about degree. Roman numeral 2, degree. Go ahead and copy this down. The largest exponent of all the variables. The largest exponent. So this is the key. We're looking for the largest exponent. Okay. Let's start with letter A here. Let's just talk about monomials. So with monomials, you'll know by looking over here to the left, it means we're not going to have any pluses or minuses. So as we look at these 3 examples, let's talk about what the degree of each one of these guys are and what we call them. On number 1, we have 4p to the first. Okay, that means this guy is a first degree. But in mathematics, we don't say first degree. What we call this is linear. Linear. We'll discuss later on in the school year what linear actually means in terms of graphs and so forth. But right now, just we'll have them up for this term. For number 2, we have 7x squared. You can see here that the largest exponent is the 2. It's a 2nd degree. But we don't call it a 2nd degree. What we call it is a quadratic. Quadratic. And then lastly, you can see over here with this number 3, the largest exponent is a 3. It's 3rd degree. And we will call this a cubic. So these are basically the 7 terms you need to be familiar with. The 4 that are over here to the left, that represent the number of terms, and the 3 here on the right that represent the degree. We need to be able to put both of them together, and we'll do so here in a moment on these examples. So let's start with, let's go ahead and put down the letter B. Like the word polynomial, so this means we're going to have many terms, which means we're going to have pluses and minuses. Here's your example. All right, so take a look at number 1. 1 has a plus in there. It's going to separate those two terms. So two terms means we're going to have a binomial. The key, though, as we look at the largest exponent is the 1 that's to the x. So this is going to be, let's see, first degree means it's going to be linear. Two terms means it's going to be a binomial. This is a linear binomial. Take a look at number 2. Number 2 has 3 different terms, which means it's going to be a trinomial. And of each of the terms, the largest exponent you see there is the 2 that's on the W. Okay, so it's going to be a second degree, which we'll call a quadratic. It has 3 terms, so this will be a quadratic trinomial. Okay, lastly, here you once again see many pluses or minuses. There's 3 of them there, which means we have many terms. It's going to be a polynomial. Of all of those terms, the largest degree there is 3. So the third degree we call cubics. This will be a cubic polynomial. Okay? All right. Let's go down and talk a little bit about standard form. Okay, so on standard form, you can copy this down for me as well. It basically says always list your polynomial terms from the greatest degree to the least degree. Okay, so what that means is sometimes these guys are going to be jumbled up. Copy down these 2 examples. Take a look at the first example. You can see we have 4 terms here, but they're not in the correct order. And what I mean by that is as you look at each degree of each term, we want to go from the highest to the lowest. Okay, so if right here, this 6x is to the first degree. The 9 over here doesn't have a variable. It doesn't have an x, so it would be to the 0th degree. It's almost like a little x to the 0 in there. It means we can rearrange these pieces in the order. Actually, not in any order, from the greatest degree to the least degree. And as we do that, we want to make sure we also pay close attention to the sign that's in front of that term. So for instance here is the largest degree here, the 7x to the third, but that degree is being, or that term is being subtracted. So I'm going to write negative 7x to the third inside. And then I go to the next highest degree, which is 4x squared. So that one's being added, so plus 4x squared. Then the next highest is the x to the first. Out here in front of the 6, there is no sign. So we would assume that that is positive, so plus 6x. And then lastly, we're at the 9. Notice how we go down here in order, from 3, 2, 1, 0. Okay, let's take the last one here. 3 different terms. We want to put them in the correct order. The highest degree is the third. That 9x to the third is being added, so we just add 9x to the third. The second term, the second highest term is the squared. It's out in front. It's going to be a positive, so we'll add it. Plus 4x squared. And the last one there is the minus x. So we got to make sure we are keeping those signs in front of the term. Okay, Roman numeral 4, let's do some practice. If you guys would go ahead and copy down these 4 problems. Now what I want you to do with these 4 problems is I want you guys to go ahead and put them in the correct order, in the correct standard form. But after you do, I want you to classify them in the correct way. In other words, give me the correct degree and number of terms. Take a moment to copy those down, try all 4, and then I'll reveal the answers in a moment. Okay, so let's reveal our answers here. On the first one, it was already in the correct order. There is 1 plus, which means there's 2 terms. The highest degree is to the third degree, so that would be a cubic binomial. On the second one, I'll rearrange the terms. X squared comes first. This is, the highest degree is 2, so it's a quadratic. There's 3 terms, so it's a quadratic trinomial. On the third one here, it's already in correct order because there's just 1 term, which means it'll be a monomial. And the highest degree is 1, so it's a linear monomial. On the last one, I kind of tricked you a little bit because we didn't talk about these. I did put it in the correct order, 5, 4, then 1, 0. We didn't talk about anything beyond a cubic, but there are other names for the 4th power and the 5th power. For instance, if you go to the 4th power, it's a quartic. If you go to the 5th power, it's a quintic. You will only need to know up to a cubic for algebra 1. technically this one should be called a quintic polynomial. Okay, take a moment, switch your paper over, take a little mental break, and then let's start talking about multiplying polynomials. Okay, go ahead and write down your learning objective on the backside. We're going to simplify polynomials using multiplication. Okay. Go ahead and write Roman numeral 1, monomial times a monomial. Here we're going to be multiplying monomials. And let's talk about these three examples here. So take a moment to copy those down. Pause the video if you need to. The first one is an example of what we did during Unit 1. They share the same base here. Y'all should remember that you need to add these exponents. So 3 plus 5 here will give me y to the 8. No sweat. The second example here has two monomials multiplied times one another. Now you might get a little confused with those parentheses, but don't. There's just a little multiplication in between there. There's no pluses or minuses, so we get to rearrange these terms in any way we want. So I'll bring the 3 and the 9 up to the front. The ends in the back. Don't forget that that's the third. So I'll get 27 in the third. Once again, still review. On the third one here, we just have more pieces, and yes, I'm using the parentheses again, but no big deal. This is all just one big multiplication clump. This may look like a subtraction, but it's actually a negative sign. It's just the software that we used here. So we can rearrange these pieces any way we want. So I'll go ahead and put the 4 and the negative 12 up front. Then I'll do the S's. Then I'll do the T's. And let's see the three pieces that we get. So 4 times negative 12 gives me a negative 48. Don't forget on the S's here that these guys have a little 1, so we're going to add all those guys up. So the 2 plus 1 plus 1 are the S to the 4th. And then 2 plus 1 plus 2, this is going to give me T the 5th. Take a moment, try these three on your own. Go ahead and copy them down, work them to the best of your ability. And here in a second, I'll reveal their answer. Okay, let's see how you did. On the first one, you should be adding those exponents and getting x to the 5th. On the second one, you should rearrange those pieces. Get 2 times 5 is 10. 1 plus 3 on your exponents. I think there's a little 1 there. Should be t to the 4th. On the last one, there's more pieces, but you shouldn't worry. The normal numbers, you get negative 3 times negative 5. That's a positive 15. Add up all those exponents on top of the x's. 2 plus 3 plus 4. That's going to give you x to the, I made a mistake. That should be x to the 9. Even the mighty Mr. Gold will fix it if you mistake it. For your y's, you got 2 plus 5 plus the 1 that's there. That'll give you y to the 8. All right. Let's go down to the bottom part of the table. Roman numeral 2. Go ahead and copy down what you see there. Monomial times a polynomial. So here we're taking the one term and multiplying it times a many term. And we'll, of course, use distributive property. Let's take a look at these three problems here. We'll work these together. You can see on the first problem here I have 4 times a trinomial. So I'm going to distribute that 4 to all three of those terms. So tippity, tippity, hoppity. So the 4 times the 3x squared, well, notice that the 4 doesn't have any variables. It's just going to affect the normal part of the number. Same thing with the middle term. And then lastly, 4 times the minus 8 gives you minus 32. Of these three remaining terms, notice that none of them are like terms. We are just set. Okay. Next one. 6p gets distributed to the two terms here. Well, notice that the term on the outside here has a normal number and also has a variable. So 6 times 2 gives me 12, and then p times p gives me 1 plus 1, p squared. On the hoppity part here, we get 6p times the minus 4. The 6 and the minus 4 combine to give you negative 24, but the 4 does not have anything that's going to affect the p. On the last one, I've got a negative 2x needs to be distributed to all three of these terms. We have negative 2 times 6 is negative 12. And then x to the first times x to the second is x to the third. On the middle one here, we have a negative times a negative. That's a positive 16, and then x squared. And then lastly, we have negative 2 times a positive 5. That's a negative 10, and there's the x that we distribute. All right, there's our answer. Okay, a lot of this is still review. It's almost like there's a bunch of mini problems that are all mixed into one big problem. I take a look at these three here, copy them down, give it your best shot, and then here in a moment, okay, let's see how you guys did. On the first one here, I'll I'll distribute the 2. It's just going to affect all the numbers that are just normal numbers. So 8x squared plus 2x plus 6. On the second one here, I threw in a little plus b there. That was kind of weird. We'll see how you guys did. When you distribute it here, 3 times 5 is 15. A squared times a to the first is a to the third. Now on the second one, notice that there's just a 1 in front of the b here. So you just get 3 times 1 is 3. And then the a squared and the b are not the same base. So basically the a squared and the b just form together to form an a squared b. Lastly, you distribute the 5r to each one of those terms. You get 5r cubed minus 15r squared minus 5r. Okay. Thank you very much. Make sure you bring this in the next time I see you. Take care.